guys. All of y'all say hey.
Hey!
All right.
Okay. Are we ready? All right, class. Today we've got a really interesting demonstration, and to do this we have two people that came along with us. First is Paul Ricaldi. He's an inventor. He has several patents. He also has his own YouTube channel. Tool companies fly him around the country just for his advice. And then we have Eric. Eric, he's kind of a Renaissance man. He's an explorer, scholar, scientist. He does a little bit of everything. So we've got Eric sitting here in our computer, and we're going to start our first lecture, and our lecture is going to be on atoms, electricity, and plasma.
Atom is Greek for that which cannot be cut. So an atom is the smallest thing that makes you up. It is what makes up everything. The screen. This is a helium atom. It has a central nucleus with 2 protons, 2 neutrons, and 2 orbiting electrons. Nature wants these atoms to be balanced, the same number of negative electrons as positive protons. The electrons have a negative charge and travel in orbitals around the nucleus. These electrons can be removed from their orbital, creating a positively charged atom and a separate negatively charged electron. This leads to our first demonstration.
What did he just tell us about electrons?
Negative energy.
Yes, neutrons are neutral, protons are positive, electrons are negative. So what do we know that uses electrons? Think about, what is it you use every day?
Electricity.
That's right, electricity. Electrons. Electricity is just the flow of electrons. So we're going to use a little demonstration here. What do you think a circuit really is? Anybody?
Something that lets all the atoms come out of it.
Close. If you think about where do the electrons go? That's the circuit. It's the path that the electrons follow. Now what we have here, y'all have probably seen these little things. These are little party ice cubes that you drop into a glass and they glow. So this little ice cube has 2 little pins on the bottom. They connect to a battery, and a little circuit connects to a light and goes back to the battery again. So if we need these 2 little things to complete a circuit, because this circuit's open, it's not actually working yet. These 2 pins are separated. Something has to combine them for that circuit to take place. So we look for some material. So we could try paper. That doesn't work. So we know paper isn't very good at conducting electricity. Or we can try plastic. That doesn't work. Rubber. That doesn't work. So what do we know about these things that don't work? Yes, go ahead.
They're insulators.
That's exactly right. They're insulators. They are insulating the electricity. So what do we need to make this contact work? Conductor. That's exactly right. So maybe my finger, can y'all see the little light? Works as a conductor. So you know the skin in your body works as a conductor. It's not a really great conductor, but it does work. And what else do we know might make a good conductor?
Metal.
That's right. See the little glow when we connect the little metal charge to it? Still not the best conductor. Miss Ricaldi, she has the best conductor. Do not try this at home. That's right.
I tried that.
Why does her tongue work as a great conductor? Yes,
Because the saliva is a liquid.
that's right. It's water, and water is a great conductor. And not only is it water, but it's what type of water? It's salt water. So that makes it work as an even better little conductor. Now, what we have here are electrons flowing through a circuit. But there's another thing that we want to talk about, which is electrons, or any charged particle, electrons or protons, that are roaming around in a gas.